And welcome back, and it's Corbett 5 a day, and we're on to the 7th of Jan. Looks like we've got a nice little mix of questions down here. Let's go with the first question. Okay, this first question is expand and simplify. Now, there's a few ways of doing this. They kind of all get you to the same place. You may also have learned a different technique where you draw a grid or similar. I'm just going to go for it by expanding the first two because they frankly look a little bit easier. So I'm going to expand these two here. So that's going to give me x squared plus 5 plus 2 is 7. 7x, 2 times 5 is 10. And then that's multiplied by 2x minus 1. Okay, and then I'm going to multiply each of the terms on the left bracket by each of the terms on the right bracket. So I'm going to basically start with the 2x, multiply by everything, then multiply by minus 1 by everything. So let's do that. So 2x times x squared is going to give me 2x cubed. 2x times 7x is going to give me 14x squared. 2x times 10 is going to give me 20x. Now, notice how I do the next step. Minus 1 times all of this is going to give me minus x squared, minus 7x, and minus 10. You'll notice I write it underneath, which just allows me very easily to add these things up. So my final answer is going to be 2x cubed plus 13x squared plus, well, 20 minus 7 is 13x again, so plus 13x and minus 10. And that's the first question done. Well done if you got that one. Next question. The line L1 has equation y equals 4x plus 3. The line L2 has equation blah. Find the gradient of line 2. Find the coordinates of the point of intersection. Okay, so we've got two different questions here. So first question is just find the gradient of L2. And the way I'm going to do that is I'm going to rearrange this equation here. So it says y equals. So it's going to be y equals. I'm going to do it in one go. So we're going to move the 5x to the other side and divide by 2. So that's minus 5 over 2x. I'm going to move the 9 to the other side, so add 9 to both sides and divide by 2. And that's going to tell me the gradient of line 2. So ML2, the gradient of line 2, is minus 5 over 2. Not too bad if you can rearrange. Find the coordinates of the point of intersection of L1 and L2. All right, so the way I'm going to do this, I'm going to start with the original equation here. And I'm going to take this y here and substitute it for 4x plus 3. So in other words, I'm going to put this y into this y here. So that's going to give me 5x plus 2. So instead of y, I'm going to write 4x plus 3. Minus 9 is equal to 0. And let's do some expanding. So 5x plus 8x plus 6 minus 9 is equal to 0. 5x plus 8x is 13x. Plus 6 minus 9 is minus 3 is equal to 0. These aren't going to be very nice numbers, are they? Which means that x equals 3 divided by 13. And y, because it says coordinates, not just the x value, but the coordinates. So I'm going to use this equation again. So 4 times 13 over 4 times 3 over 13 is 12 over 13. Let's write this down because it can be a bit messy. Plus 3, which is the same as 39 over 13. So in other words, I've created a fraction out of that. And that's going to be, well, 39 plus 12 is 49/51 over 13. So it's not a nice answer, but the answer to this question is going to be 3 over 13, 51 over 13. Well done if you got that. That's not very nice at all. Next question. Okay, obviously in the next question, you could do this in twos, but because 4 squared is 16, we can just do it straight away in powers of 4, couldn't we? So if I rearrange this one, well, that's going to be 4 squared x. This other one is already in terms of 4, so I'm just going to write 10 minus x. Expand my brackets, which means that 4 to the 2x is equal to 4 to the 10 minus x. Because my base values are equal, it must therefore be true that 2x is equal to 10 minus x, which means that x is equal to, well, add x to both sides, I've got 3x, 10, and so therefore x equals 10 over 3. It looked a lot worse than it was, didn't it? So therefore x equals 10 over 3. Well done if you got that. Okay, final question. What does he want? Show that the area of ABCD, in other words, the whole area of the two triangles together, is equal to 112 or 1212x squared. Okay. No, this is a difficult question, isn't it? I'm trying to think of an easy way of doing it that doesn't involve me finding the height like this, but I can't think of a way of doing it. So therefore I'm just going to do the long method. I'm also going to have to find the length of AC. So there's quite a lot to this question, isn't there? So let's, I think space might be okay. Let's try over here. So first of all, AC is equal to the square root of 24 squared. Let me get my calculator right. 24 squared, which is 576 x squared, plus 10 squared. Well, I do know what that is. So that's 100 x squared, which is equal to, well, 576 plus 100 square rooted. Okay, good. Is 26. In other words, that's reassuring because that's a nice number. It's 26x, which means that I also know that halfway across is 13x and 13x. And the reason I need that is because I need to work out the height of this triangle here. So the height of my triangle is going to be the square root of 85x squared minus 13x squared. So I'm again using Pythagoras again. So in my calculator, I'm going to do 85 squared minus 13 squared, which square rooted, which, oh, that's a nice number as well, which is going to give me 84. Now the x squared, I'm doing x squared minus x squared and then square rooting. So in other words, that's just going to give me x. So actually that's not too bad at all. And then I just need to put it all together. So therefore the height of the overall shape, or the triangle down here, the smaller triangle, its area is going to be a half times the height, which is 10x, times the base, which is 24x. And the big triangle is going to be a half times the base, which is 26x, times the height, which I've just worked out to be 84x. So let's get my calculator and do this carefully. So 0.5 times 10 times 24 is going to give me 120x squared. And then I'm going to add on a half, 0.5 times 26 times 84, which is 1092x squared. Add these things together, so plus 120, and I do indeed, thankfully, get 1212x squared. Always reassuring when you get the answer you're supposed to get. And that's ended today nicely. That's actually quite a nice little set of questions, isn't it? Wonder if you got these. As ever, do like, comment, leave a comment below and I will reply to you. Do make sure you subscribe to the channel so you can see more of these coming through, and I'll see you for the next one. Thanks all.